There is a war between chaos and order that defines the way our universe works. On one hand, we have the natural laws of physics and chemistry, and among other laws that are unbreakable and unchangeable, and they just define the way the world works. But on the other hand, we have this nature of how events are supposed to unfold over time in this unpredictable and chaotic way that we just can't predict the future. Now, this problem of order versus chaos is very prevalent when artists are trying to draw very complicated things. And this is something I like to call the tree problem, because trees are just a really good example of this occurring. On one hand, artists may try to draw trees a little bit symbolically, but where we can recognize them as trees, but they're just too regular and they're too simple to look natural. On the other hand, we have artists who try to draw the chaos, but they don't really know how they're going about drawing the chaos, and it just looks like a convoluted mess, like a tumbleweed that is made up of branches and leaves instead of an actual natural tree. Now, the big question is, what is just right? What is that balance between complexity that defines what looks natural and the order that makes something look familiar? The solution to this problem can actually be found in math, surprisingly. French-American mathematician Benoit Mandelbrot, with the combined genius of other mathematicians from his past, came up with this idea of the fractal. And what the fractal is it's just a shape or a pattern in geometry that is self-similar. And self-similarity is defined by the fact that it repeats within itself and it varies its repetition within itself indefinitely. Now, I understand that a lot of artists will probably be thinking, well, why is this important? This is math. I'm an artist. Is math really important that I need to know about it in a drawing? And my answer is that, the math part is something that we can sort of overlook, but fractals are actually more important than you think. It's actually more prevalent in what we want to do in our art. And we can see this just by looking at nature. Take a look at trees. And the reason why I brought up trees in the first place is because the way they look, their personality, if you would, is based on their fractal pattern. The angle of one part of a tree to another, the angle and the proportion defines their personality, how they look. Also, mountains are just triangles reiterated in a very complex way. Clouds are also, they're also these reiteration of shapes. And our anatomy is a very important example. The fact that we can divide our anatomy into head proportions, the fact that the cowstate cool as a rhythm exists so prevalently, not just in our gesture, but in our anatomy. It's because fractals make all of this possible. And now, the reason why Mandelbrot came up with this idea of the fractals, because, well, he didn't agree with the other mathematicians who saw this disconnect between math and nature, this idea that, math is about clean lines and curves. But no, clouds are not spheres. Mountains are not cones. This is what Mandelbrot said. He saw that this idea of the fractal is this answer to nature's complexity and familiarity, this ultimate balance between chaos and order. And what we can take from this is that this idea that, nothing's ever actually random. Take a look, for example, and take a look at this example, for instance. Like, someone goes around with a hammer and smashes a bunch of rocks. And if you look at these rocks, the cracks, the shattering on each individual rock is going to look different, just because they're going to look different. But we can tell that they've been hit by a hammer, not just because we know the hammer exists, but because those cracks follow certain tendencies, and these tendencies will change based on these variables. These variables such as like the angle of the impact, the mass of the hammer, the type of rock, etc., etc. And the reason why things seem random is this fact that there's so many of these variables and we simply just can't predict all of them. Which is why photo reference is really important, so we can grab as much information as we can. But when we're drawing, we have to realize that these variables are all there. They are there, and we have to look for them. But the way we can go about this, the way we can go about drawing something complex is by breaking it down, simple to complex. Start from the simplest part of the fractal and layer that simple over and over and over and over until you get, and then vary it too, and vary it correctly also. Find out the proper fractal pattern and vary it, and layer that simple, and then you will get this natural feeling of complexity that looks recognizable. So in the end, just keep in mind, whether you are doing a shadow shape study or you're looking for the rhythm in a gesture, or an anatomy, or even if you're writing a story or doing anything for that matter, just remember that fractals are behind all of these things, and that contrast may be the meaning of life, but without fractals, there's no life.